My name is Antonio Gramaglia, and in this slideshow, I will be talking about information behaviors of web developers using JavaScript and React. So, what is information behavior? Well, by definition, it is the ways individuals seek, use, and share information. And it's important because understanding information behaviors can help improve how developers learn and share technical knowledge, especially in fields that need to use coding languages such as JavaScript and React. It can also help refine teaching methodologies and improve tools like ESLint. So, what exactly is ESLint? Well, it is a static code analysis tool that helps development teams identify and fix issues in JavaScript and React. So, an overview of all 6 sources that I've used. There was plenty of different research questions, but they all kind of concluded to this main question, which was how web developers seek, use, and share information to tackle challenges based on React and JavaScript. And there was tons of different methods, but I did see a significant amount of interviews in this. There was also plenty of case studies, surveys, and prototype testing. And summarizing these articles, they kind of also came to the same conclusion about what they found with their research, and it was pretty much just highlighting developers' learning barriers, reliance on tools, and the impact of educational methods. They also covered key challenges like accessibility, experimental learning, and productivity enhancing tools. The first article that I found was uncovering threshold concepts in web development. So obviously they had many talking points about React and JavaScript, but the main focus was about identifying difficult concepts in JavaScript and responsive design. And the method they used were mainly interviews with web development instructors. And the main finding about this source was how these threshold concepts are crucial for curriculum design, ensuring developers overcome key learning barriers. My second article was titled Accessibility in Web Development Courses, and the main focus was how important it is to teach accessibility in web development. And the main method they used were case studies with students in web development courses, which I feel like kind of floats my boat because that's literally what I am. So that's the main reason why I chose this source. And the main finding was accessibility knowledge is lacking but critical for building inclusive web applications. My third article was web-based development of information system administration, and the main focus was using web-based tools for managing administrative systems. The method they used were development and testing of a prototype system. So these people created their own code that would help them kind of find their own research because it was firsthand and they were seeing what was there. And their main findings were highlighting developers' need for streamlined, user-friendly tools to enhance productivity. And I feel like it's very cliche to say, but obviously if something's easier to read, something's easier to manage, then you're going to get more results out of that in terms of finding research for it. My fourth article was titled The Adoption of JavaScript Linters in Practice. The main focus of this was examining how developers adopt and use tools like ESLint. I explained that earlier, and that is very important because I feel like you need to identify your issues, because if you don't, then your code's not going to work. And the main findings about this, it's just adoption helps reduce errors, showing developers' reliance on automated tools for quality assurance. And this was what I wanted to say for last was there was a case study on GitHub repositories. And I feel like when you're first learning how to code, GitHub is definitely one of the most annoying and difficult things to learn because there's so much stuff there. But after they come up with a case study, they had students and professors, I remember correctly, and they just kind of used their own repositories just to see what they could find. My fifth article was experimental learning in web development courses. So the role of hands-on learning and improving student outcomes in web development was the main focus for this. And this was also another source that I related to because this is my actually third web development course that I'm taking this semester. So I have another essay that I'm writing, and I was kind of taking inspiration from this as well. The main method they used for this was surveys and performance of data analysis. And the findings that they found were experimental learning can improve understanding of complex concepts like React frameworks. And I'm firsthand to say it, and it is true because when you're first learning React, it is very difficult to kind of understand. But as you use it, you definitely, you know, you just get better at it, just like with everything else. My last article was called Resumability, a new primitive developing way of creating web applications. The main focus of this was it introduces resumability as a method for enhancing web applications. Resumability is just basically creating something and stopping where it's something easy to pick back up onto. And the main method they used for this was case studies of prototype implementation. And what they found in this research was the new primitive streamlined performance, showing how developers seek efficiency in tools. So I don't like to say that React is more of a coding language because it's not, because it just uses JavaScript. So I would consider React a tool, because that would definitely help coders develop and just kind of understand JavaScript as a whole. So here's part one of my critique. These are going based off of the strengths. So forgive me, I don't want to butcher these names, but here are the addressing key educational gaps by Alston. It effectively highlights threshold concepts, providing actionable insights for curriculum designs. These findings guide educators to address challenging topics like asynchronous JavaScript and responsive design, enabling better learning outcomes. Practical tools for developers by, I'll just call him Thomas. It demonstrates how adopting tools like ESLint reduces coding errors and improving software quality. The study bridges research and real-world application by showcasing how developers actively integrate automated tools into their workflows. Emerging themes across studies. So collectively, these studies emphasize trends like the importance of hands-on learning and the growth reliance on streamlined, efficient tools, which can shape the future of developer education and productivity. And obviously, there's strengths in every research papers, and there's also weaknesses. So there was a narrow focus and limited applicability. It concentrates on administration systems, limiting generalizing to broader web development concepts. The narrow scope reduces its relevance for developers beyond specific case studies. Forgive me, it's so hard to say these names. Ferrati and Vogel focuses primarily on accessibility education, which, while crucial, overlooks broader technical and behavioral challenges faced by developers. Methodological limitations. The lack of mixed method approaches. These studies predominantly rely on either qualitative interviews or case studies, missing opportunities for more robust data triangulation. A combination of quantitative and qualitative methods could provide better insights. And I feel like I had the best luck when I would find a source or article that did hands-on stuff, and that would create their own code blocks and just get their research based off of that, because it's right there. And there was missed opportunities for broader impact. Several articles failed to explore interdisciplinary actions, such as how findings could benefit non-technical fields or enhance collaborative practice in teams. And that's something that's kind of really important for me, because I feel like whether you're in a technical field or not, there's a lot of stuff in those fields that could just relate and be important for other stuff, like maybe something for engineering or business. Future directions in information behavior research. So I'm really big on AI. I just think it's very interesting. One of my first coding projects was a AI image generator, and I used an API from ChatGPT. So the images weren't really clear, but you could definitely tell what you were trying to input into the box. Adopting cross-disciplinary perspectives. So expanding research to include cognitive science and learning theories could reveal how developers process complex technical information and adapt to new tools. A focus on collaboration. So investigating how information is shared in team environments, including the role of mentorship and peer collaboration in professional settings. ethics and information behavior. So exploring the implications of relying on open source resources like AI generated code, particularly in maintaining quality and ethical standards. Methodological innovations. So mixed method approaches combine qualitative insights with qualitative metrics to provide a holistic understanding of developer behaviors. Longitudinal studies, examining how developers' information seeking strategies evolve with advancements in tools like React and the emergence of new paradigms like resumability. So, here are my personal reflections. So, I recognize the importance of structured search strategies for finding relevant resources, such as filtering by source credibility and using targeted queries, especially how I have two sources that were related to me in a way how I was taking a course based on React, based on information behaviors. So I would like to find sources that were similar to that. I gained an appreciation for hands-on learning, seeing it as a crucial complement to theoretical research and grasping complex frameworks like React. I developed skills to critically evaluate sources, ensuring information in both reliable and applicable to specific technical challenges. So, some key insights from the research process were I realized the relevance of threshold concepts in addressing learning barriers, as highlighted in studies like Austin, understood how tools like ESLint play a significant role in improving productivity and reducing errors, and I reflected on the iterative nature of research, where challenges in methodology and scope refinement lead to better outcomes. So how can I apply this to my academic and professional life? Well, I plan to apply these insights by promoting effective knowledge sharing and collaborating problem solving in team settings. And I feel like you grow the most when you're in a team setting. So for example, a classroom, but most importantly, an internship or job, because you're learning from people that already know what you're doing. And it's aimed to leverage learned strategies to navigate new and emerging technologies in professional projects and use enhanced information seeking behaviors to support lifelong learning and continuous skill development in this fast-paced tech industry. And what I've been noticing is a lot more people are trying to come into the world of like coding and technology because they hear the pay is good or it's just very interesting. And we're in a world right now where everything is just computer based, so I'm not really surprised by seeing that. Here are my references, and thank you.